All right, we're going to finish up chapter 15 today. We're going to cover section 2 and 3. So, starting with section 2, energy conversion and conservation. So, energy conversion, it's the process of changing energy from one form to another. So, for example, if we're going from mechanical energy to chemical energy, from electrical energy to thermal energy, those are all conversions. And energy also has to be conserved. So the law of conservation of energy states that energy cannot be created or destroyed. That is very important. Please make sure that you write that down. Now, we can convert from potential energy to kinetic energy. We saw that when we went through first section, where you could solve for potential or kinetic, either one. And basically what this says is that the gravitational potential energy of an object is converted to the kinetic energy of motion as the object falls. So the potential energy an object has while it's sitting on a shelf, let's say a ball for example, as it sits on the shelf it has potential energy but no kinetic energy because it's not moving. Once it is knocked from the shelf and begins to fall, its potential energy starts changing into kinetic energy. And just before it hits the ground, it no longer has any potential energy at all. It's all been converted into kinetic energy. And we're actually going to do a lab in the computer room that will help you look at potential energy and kinetic energy. Now, calculating potential energy to kinetic energy, you have a beginning, you have an end. So the kinetic and the potential in the beginning has to equal your kinetic and your potential at the end. So, for example, if I give you that a 1.50 kilogram brick is dropped from rest and it hits the ground at a speed of 26 meters per second, I want you to find the gravitational potential energy of the brick before it was dropped. Now, in this case, we're going to look at this as potential energy is equal to kinetic energy, because we're looking at this as right before it hits the ground. That's your speed of 26 meters per second. And we're trying to find it before it ever dropped. So we're looking at the two extremes here. So we're going to use the kinetic energy formula because I gave you kilograms and I gave you meters per second. That fits into the KE formula, not the PE. So 1/2 times the mass, 1.5, times V squared, which is 26. So half of 1.5 times 26 squared. And when you plug all that in, you should get 507 joules. So practice problem, if I tell you a 10 kilogram rock is dropped and hits the ground below at 60 meters per second, find me the kinetic energy. So same thing that we did in section 1. We're still looking at KE and PE, but I'm wanting you to be able to solve for it no matter what I ask. Look at what you've been given, kilograms and meters per second or kilograms and meters. That tells you which formula to use. Now, energy and mass can be converted into each other. So energy can turn into mass. Mass can be converted into energy. And the way that happens was something that Albert Einstein came up with as E equals mc squared. So your energy has to be equal to your mass multiplied by the speed of light squared. And we're not really going to go a whole lot into detail about that, but we will talk a little bit more about Einstein. So section 3, energy resources. These are all of the different types of resources, and you should know these from earth science, but we're going to briefly go over them again. Non-renewable energy cannot be replaced over the course of millions of years, so it takes a very long time for this to be replenished. So we will run out of these things very quickly. So oil, natural gas, coal, uranium, those things are non-renewable. Fossil fuels, those are non-renewable. They are underground and they are formed from once living organisms. Renewable energy, it means it can come back quickly. So think about trees, life cycle, hydroelectric, so water, solar, heat, wind, all of these things that we can renew or get back pretty quickly. So hydroelectric energy, that's the first. It's obtained from flowing water. And if anyone can tell me the name of the place where this picture was taken, then I'll actually give you some extra points. Solar energy, sunlight that is converted into usable energy. So we have solar panels. Solar energy, the problem with this is that it's very expensive on startup, but once you get it going, it's pretty decent to maintain. Geothermal energy, so we have geo is earth, thermal is heat. So we're looking at hot masses of energy beneath the Earth's surface. So think of geysers, those are hot water energy balls. Biomass, so think of chemical energy. This is from living things, so think of corn, vegetable oil, those type of things that can be used for diesel. Hydrogen fuel cells, so we're taking hydrogen and oxygen and we're generating electricity by converting this and getting the energy from when it converts into water. So hydrogen gas in, oxygen gas in. When it makes water, you get this almost like this miniature explosion that emits energy. Conserving energy, we can reduce energy needs, we can recycle, we can reuse things. Being more efficient in how we use our energy, that's all very important. So think of where we're recycling in class. You see the paper, you see the bottles that we're recycling. All of that's to help conserve energy. So find ways to use less energy or use it more efficiently. So like if you're at the house or if you're at home and you have lights on in every room, if you're not in that room, turn the light off. If you are watching TV and you decide to leave the room, turn the TV off. If you are brushing your teeth and you leave the faucet running, turn the faucet off until you need to use the water again. That's using less energy. And that's it for chapter 15.